There is a secret woven into the fabric of the cosmos, a secret so vast, so invisible, so silent that for most of human history, we never even knew it existed. Look up at the night sky. Every star you see, every galaxy, every glowing cloud of dust, every planet, every moon, every atom, all of it together makes up just 5 of the universe. The remaining 95, the overwhelming majority of existence, is completely hidden. It does not shine, it does not reflect, it does not emit, it does not behave like matter, and it does not obey the rules we understand. It is invisible, untouchable, mysterious, and yet it shapes everything we see. Tonight we enter that unseen world, a world made not of stars but of shadows, a universe where the laws of physics whisper, where galaxies dance to forces they cannot see, and where the greatest mystery of all is not what we observe but what we never could. And before we begin, if you enjoy calm journeys like this, you're welcome to subscribe to Theories for Sleep. Only when you're comfortable and only when you are ready. Now welcome to the dark universe, the 95 that hides behind everything. For as long as humanity has looked up at the night sky, we believed we were seeing the universe, the glimmer of distant stars, the faint clouds of nebulae, the soft band of the Milky Way stretching across the darkness. All of it felt like the complete story, as though the cosmos had revealed its full face to us. But the more we learned, the more we discovered how wrong we were. Because everything we can see, every shining object, every glowing star, every galaxy, every atom that emits or reflects light makes up just 5% of all reality. 5% to describe everything we thought was everything. The remaining 95% is invisible and untouchable, not because it's far away, but because it does not shine, it doesn't glow, it does not interact with light at all. It is a universe hidden inside the universe, a universe behind the curtain, pulling every string while refusing to ever step onto the stage. Tonight, we begin to walk into that darkness, into the shadow world that surrounds us, into the quiet, powerful realm that shapes existence without ever revealing itself, the dark universe. To understand where this story begins, we must travel back to the earliest moments after the Big Bang, a time when everything glowed, when the universe was young and brilliant. This early cosmos was a storm of energy and light. Particles collided in every direction. Space itself was hot, dense, and chaotic. Nothing could hide. Every atom was luminous. Every movement left a trail across the newborn sky. But as the universe expanded, as it cooled, as the first atoms formed, a quiet transition occurred. The universe became darker. Not because light disappeared, but because something else emerged. A kind of matter that produced no light at all. Matter that passed through stars and planets as though they weren't there. Matter that existed everywhere, but would not be seen anywhere. This strange presence remained unknown to us for billions of years. Humanity saw the galaxies spinning, but we never realized there was something much larger holding everything together. It wasn't until the 20th century that we noticed something odd. Galaxies behave as though they contain far more mass than their stars can account for. Their outer stars spin too fast. Their arms hold together too tightly. Their clusters refuse to drift apart. By all logic, every galaxy in the universe should have flung itself into chaos long ago. But they haven't. Something invisible is acting as the glue. Something massive. Something present in enormous quantities. Something powerful enough to bind entire galaxies, not just one or two, but all of them. This invisible matter was eventually given a name: dark matter. Not because it behaves like darkness, but because we cannot see it at all. Dark matter does not shine, does not absorb light, does not reflect it, does not scatter it. To every telescope ever built, dark matter is completely invisible, a ghostly presence, passing silently through the universe. And yet without it, nothing we recognize would exist. Galaxies would fall apart. Stars would drift into cold space. Clusters of galaxies would unravel. The cosmic web would collapse. Dark matter is the silent architect holding the universe together. But to truly understand this darkness, we must step inside a galaxy and explore what cannot be seen. Imagine drifting above the Milky Way. You see its shining arms, its glowing core, its clouds of gas, its billions of stars. That is the visible Milky Way, the 5%. Now imagine a second Milky Way surrounding the first, a massive spherical halo stretching far beyond the stars. This second version is not made of light. It cannot be photographed or observed. But scientists know it is there because without it, the visible galaxy makes no physical sense. This halo is made entirely of dark matter. It is larger, more massive, and more fundamental than the shining galaxy inside it. The Milky Way we see is just a decoration, a thin glowing layer resting inside a vast, invisible shadow. Every star in the galaxy orbits inside this halo. Every movement it makes follows the instructions of dark matter-esque gravity. The real Milky Way is not the glowing spiral you know, but the invisible sphere you cannot see. And when we zoom out to view the universe on the larger scales, this pattern repeats. Every galaxy sits inside a dark matter halo. Every cluster of galaxies is held together by dark matter. Every filament of the cosmic web is woven from dark matter. The bright universe is merely paint on top of a much darker canvas. And yet even dark matter is only the beginning of the story. Because as scientists mapped the universe, measuring distances between galaxies, tracking how they move, watching how the cosmos expands, they discovered something far more shocking. The expansion of the universe is not slowing down as gravity pulls everything inward. It is speeding up. Galaxies are not drifting apart gently. They are accelerating away from one another with a force that increases over time. Something is pushing space outward. Something is acting like the opposite of gravity. Something is overwhelming the pull of every galaxy and every cluster and every star. This mysterious pressure was given another name: dark energy. Not because it behaves like energy we know, but because it acts like an invisible pressure stretching the cosmos wider and wider and wider, and it will not stop. Dark energy is not a force within the universe. It is the expansion of space itself. Where dark matter pulls, dark energy pushes. One binds, one separates, one forms galaxies, one scatters them, one shapes the cosmic web, one tears it apart. The universe is a battle between dark matter and dark energy. A battle we can see, but we can feel in the way galaxies move and in the way the cosmos stretches. And here is the most shocking truth. Dark matter makes up about 25% of the universe. Dark energy makes up about 70%. Together, these two invisible forces make up 95% of everything that exists. Everything you see, every atom in every galaxy, in every corner of the cosmos is just the remaining 5. We are living in a universe that is almost entirely hidden. A universe where the visible world is a tiny island floating in a vast dark sea. This is where the story truly begins. But we are not finished with part 1 yet. This was only the first half. Now we go even deeper into the structure, the experiments, the evidence, and the mysteries that define the dark universe. To truly understand the dark universe, we have to explore the evidence that led us here, the quiet clues scattered across the cosmos that reveal an invisible presence shaping everything we know. Because the universe did not whisper its secrets, it hid them in plain sight, and only by following the smallest details did we begin to uncover the vast hidden architecture beneath. The first clue, the speed of stars. When astronomers first measured how fast stars move around their galaxies, something strange appeared. Stars far from the centre were orbiting too quickly. In a normal galaxy, like our solar system, objects farther away should move more slowly, just as Pluto drifts slowly around the Sun, while Earth moves faster. But galaxies don't behave this way. The outer stars were moving at almost the same speed as the inner ones, as if something massive and invisible was pulling them with incredible strength. Gravity was stronger than the visible matter could explain. It was as if the galaxy was surrounded by a gigantic, unseen mass, an invisible halo holding everything together. This was not empty space. This was dark matter. The galaxies were telling us, through their motions, that they contained far more material than their light. Revealed, the stars were obeying a hidden force, and slowly we began to see the outline of the dark universe forming around them. The second clue, the bending of light. Light, even across billions of years, can be shaped and distorted by gravity. A massive object like a galaxy cluster can bend light passing around it in the same way a lens bends the light of a candle. This effect, called gravitational lensing, allows us to see mass even if it emits no light at all. When scientists observed distant galaxies through the gravitational lens of other galaxies, they found something astonishing. The amount of bending was far greater than the visible matter could create. There was more mass than the stars could explain, more gravity than the luminous objects could account for. It's as if a giant dark hand was shaping the paths of light from behind the scenes. The invisible became undeniable. Dark matter was not just holding galaxies together, it was bending the very fabric of space around them. The third clue, the structure of the universe. When cosmologists mapped the distribution of galaxies across the universe, they noticed a pattern. Galaxies were not scattered randomly like grains of sand. They were arranged in long interconnected filaments, structures that stretched across hundreds of millions of light years. These filaments formed the cosmic web, a giant three-dimensional network of galaxy clusters and voids. But here's the strange part. When scientists simulated the universe using only ordinary matter, the cosmic web did not form. Galaxies fell apart, structures collapsed, the web never appeared. But when they added dark matter invisible, massive, frictionless dark matter, the cosmic web came to life. Every filament aligned, every cluster behaved correctly, every void settled into place. Dark matter was the blueprint, the skeleton, the architect. It was shaping the universe from the moment it began. The visible cosmos was simply following its design. The fourth clue, the echo of creation. If you look far enough into space, you look back in time, and if you look 14 billion years back, you reach the afterglow of the Big Bang, the cosmic microwave background. It is a faint map of the infant universe, a pattern of tiny temperature differences spread across the sky. These temperature patterns act like fingerprints of the early cosmos, and they tell us the same story. The early universe contained much more matter than we can see today. It contained a hidden mass with a hidden influence, a mass that shaped the first atoms, guided the first structures and determined the evolution of everything. This mass was dark matter. The afterglow of creation confirms its presence. The universe began with darkness woven into its foundation. So what is dark matter? The truth is we still don't know, but we know what it isn't. It isn't atoms, it isn't a gas, it isn't a dust, it isn't a black holes, it isn't a planets, comets, or stars. It doesn't interact with light, doesn't collide with other matter, doesn't absorb energy, doesn't release it. Dark matter is a quiet passenger in the cosmos, invisible, silent, yet overwhelmingly influential. We suspect it may be made of exotic particles, WIMPs, axions, sterile neutrinos, particles that drift through space like shadows through fog. But none have ever been detected. Dark matter remains one of the greatest mysteries in all of physics, and yet this mystery is only half of the dark universe, because dark matter pulls. But dark energy pushes, and its influence is far more dramatic. The discovery of dark energy. In the late 1990s, 2 teams of astronomers were studying distant supernovae explosions so bright they can outshine an entire galaxy. These supernovae act like cosmic lighthouses. Their brightness tells us how far away they are. Their colour tells us how fast the universe is expanding. Scientists expected to find that the expansion of the universe was slowing down because gravity should pull everything inward. Instead, they found something shocking. The universe was expanding faster today than it was billions of years ago. It wasn't slowing down, it was speeding up. Something was pushing galaxies apart with increasing force, something that overpowered all the gravity in the cosmos. This force, this invisible, accelerating pressure, was named dark energy. And the more we measured, the more we realized just how dominant it is. Dark energy makes up almost 70% of the universe. Dark matter is about 25%. Everything else, everything we know, is only 5%. We live in a universe built almost entirely from things we cannot see. Dark energy does not behave like anything we know. It isn't a force pushing galaxies apart like wind or pressure. It is far stranger. Dark energy is the expansion of space itself. It is space growing, stretching, inflating, not because of motion, but because the fabric of reality is expanding. Imagine dots painted on a balloon. As the balloon inflates, the dots move apart not because they move, but because the surface beneath them expands. Dark energy is the inflation of the balloon. Galaxies are the dots. Space is growing between everything, and the more space grows, the more dark energy dominates, causing even faster expansion in a runaway process that will determine the ultimate fate of everything. Dark energy may one day pull galaxies so far apart that none will be visible to each other. A universe of islands adrift in infinite darkness. Perhaps even the atoms themselves may one day be torn apart depending on the true nature of this invisible pressure. But that part of the story belongs to a later chapter. For now, our journey continues deeper into the mystery itself. What is dark energy? Where did it come from? Is it constant or changing? Does it have a source, or is it woven into the fabric of space? These questions shape the foundation of the remaining chapters of our story. For most of cosmic history, the universe expanded slowly, steadily, predictably. Gravity, the quiet architect of structure, pulled everything inward, gathering atoms into stars, stars into galaxies, and galaxies into vast clusters held together like families of ancient light. But as the universe aged, something changed. Something subtle, yet immense. The expansion of the universe should have slowed down. Galaxies should have tugged at one another like neighbours tied by invisible ropes. Space should have relaxed into a calm, stable rhythm. Instead, the universe did the opposite. It accelerated. It chose motion over stillness, speed over rest, separation over structure. This was the first whisper of something far stranger than dark matter, an unseen energy woven into the empty spaces between galaxies, a force that does not pull or collide or vibrate, but stretches the very fabric of reality. This was the discovery that changed everything. Dark energy. To understand dark energy, we must first understand what we mean by empty space. Because space is not empty, not truly. It is not a silent vacuum. It is not a blank canvas where matter simply drifts. Space is a fabric, a substance, a field of possibilities that can stretch, bend, twist, ripple, and even break. Every particle that has ever existed is a vibration on this fabric. Every force that has ever acted is a curvature within it. So when we speak of space expanding, we do not mean that galaxies are flying apart like fireworks. We mean that the fabric beneath them is stretching. Imagine two small boats floating on an ocean. The boats are at rest. They do not move. But the water beneath them rises and lowers, carrying them apart without their engines ever turning. That is how galaxies behave. Not because they move, but because space itself carries them. Dark energy is the rising tide. But what is this energy? To answer that, we must go deeper into the fabric itself. Every cubic centimetre of space, every tiny region smaller than an atom is filled with quantum fluctuations. Particles appear and disappear. Fields shift and return. Energy flickers into existence and fades again in an endless silent dance. This sea of quantum motion does not rest. It does not reach zero. It does not sleep. And according to some theories, this constant vibration creates a subtle pressure, a pressure that accumulates throughout the entire universe. Even the smallest force becomes unstoppable when multiplied by every point in existence. This may be the origin of dark energy, not a force, not a particle, not a field we can isolate, but simply the restless nature of empty space. If this is true, then dark energy is not a visitor entering the universe. It is the nature of space itself, a property of the void. The quiet truth that emptiness is never truly empty. But here lies the paradox. When scientists calculate how much energy empty space should contain, their predictions are catastrophically wrong. Not slightly, wrong, not double or triple. The difference between theory and observation is one of the greatest mismatches in the history of science. Quantum physics predicts a vacuum energy so enormous that the universe would tear itself apart instantly, while observations show a tiny, delicate value, just strong enough to accelerate the cosmos, but gentle enough to allow galaxies, stars, and eventually life to form. The universe behaves as though dark energy has been finely tuned with extraordinary precision. Too strong and nothing would exist. Too weak and expansion would slow, collapsing the cosmos back into fire. But the value we observe is not too strong and not too weak. It is perfect, unlikely, mysteriously balanced. Balanced so precisely that even the slightest shift would erase everything we know. This is not just puzzling, it is astonishing. It raises questions far deeper than physics alone. Why is dark energy so small, so gentle, so perfectly matched to the needs of a universe that can host life? Is it a coincidence, a miracle, a necessity? Or is there something more, something we have not yet imagined? To explore this mystery, we must examine the possibility that dark energy may not be constant. It may be changing, slowly, silently, across billions of years. Because even though the universe is expanding faster today than in the past, we do not know if that expansion will continue forever in the same way. There are several possibilities, each painting a different future for everything that exists. Possibility 1. The universe expands forever. In this scenario, dark energy remains constant. Galaxies drift apart. Clusters unravel. Stars exhaust their fuel. New stars stop forming. Black holes evaporate. And in the far future, the universe becomes a cold, dark ocean of lonely particles drifting apart forever. This is the heat death scenario, a future where time continues but meaning fades. Possibility 2. Dark energy weakens. If dark energy slowly fades, gravity may one day regain control. Galaxies may begin to drift closer. Clusters may merge. The universe may slow its expansion and begin collapsing back inward. A reverse Big Bang, a cosmic implosion called the Big Crunch. All of existence returning to the fire from which it came. Possibility 3. Dark energy strengthens. If dark energy grows stronger, the expansion of the universe could accelerate uncontrollably. Galaxies would separate, then stars, then planets, then atoms, and eventually even space-time itself would tear apart. This is the Big Rip. Not with fire, but with silence. Possibility 4. Dark energy oscillates. Some theories suggest dark energy may rise and fall in cycles, creating a universe that expands and contracts over trillions of years. An eternal rhythm, a cosmic heartbeat, a universe that breathes. Possibility 5. Dark energy is not what we think. Perhaps we misunderstand everything. Perhaps dark energy is not an energy at all, but a sign that our understanding of gravity is incomplete. Maybe gravity behaves differently on the scale of galaxies and cosmic filaments. Maybe space itself is not smooth, but structured in ways we cannot perceive. Maybe we live in a universe whose true laws are still hidden behind a veil of shadow. But the truth is this: whatever dark energy is, it is winning. Today, dark energy dominates everything. It defines the future. It shapes the horizon. It determines the destiny of the cosmos. Dark matter built the universe. Dark energy will end it. One sculpted the past. The other sculpts the future. Together, they form the dark universe, a silent, invisible realm that surrounds us and yet remains unknown. To understand the dark universe, we must travel back in time far beyond the first star, far beyond the first galaxy, far beyond the glowing afterlight of creation, to the moment when the universe was still formless, hot, dense, and filled with energy that had not yet decided what it would become. Because the seed of everything dark, both dark matter and dark energy, was planted in the earliest breaths of the cosmos. Before the first atom existed, something invisible was already there. The universe in its infancy was not a place of stars or planets. It was a storm, a furious ocean of particles colliding at unimaginable speeds. Photons ricocheted through space as though bouncing inside a furnace. Matter and antimatter annihilated one another in flashes of pure energy. Fields vibrated with chaotic intensity, and yet beneath all that chaos a pattern was forming. Not in light, not in atoms, not in anything we could see, but in the invisible. Dark matter began its quiet existence long before normal matter took shape. The birth of dark matter. Normal matter, the matter that forms stars, planets, and life, could not exist until the universe had cooled to a certain temperature. But dark matter does not care about temperature. It does not interact with light. It does not heat up. It does not cool down. So while ordinary matter waited for the universe to settle, dark matter moved freely. Long before the first atom formed, dark matter was already spreading through the universe like a calm shadow moving through a storm. It didn't collide with anything. It did not slow down. It simply drifted, guided only by gravity. Where normal matter struggled, dark matter glided. It flowed into patterns shaped by the subtle variations in the early universe, tiny fluctuations in density that would one day become galaxies. And like a silent artist, dark matter began to paint the first outlines of cosmic structure. It formed invisible clouds long before any star existed. It gathered into halos before any galaxy was born. It shaped the gravitational landscape into which atoms would someday fall. Dark matter, though unseen, was the first architect. Normal matter was only the finishing touch, the invisible blueprint. As the universe expanded and cooled, ordinary matter finally began to form atoms. These atoms clumped together, creating the first clouds of gas. The gas collapsed under gravity, igniting the first stars, but these stars did not appear randomly. They formed exactly where dark matter had gathered. Dark matter did not simply influence the universe, it designed it. Imagine a map with invisible valleys and peaks. Ordinary matter flowed into the valleys, the regions where dark matter had collected. These valleys became galaxies. These peaks became voids. These threads became filaments stretching across billions of light years. The visible universe is merely the bright ink drawn on top of the dark blueprint beneath it. The first galaxies. When the first galaxies formed, they were not elegant spirals like the modern Milky Way. They were chaotic, turbulent, fragmented. Violent collisions between early galaxies scattered stars across space. Massive black holes tore through the cores of newborn structures. Stellar winds blasted away gas from infant star clusters. But through all this chaos, dark matter halos remained stable. They absorbed the shocks, captured the fragments, and provided gravitational wells that allowed galaxies to survive their violent youth. The first galaxies were fragile, but their dark matter halos were unbreakable. This is why galaxies, despite their turbulence, exist at all. Without dark matter, the early universe would have been a place of scattered light with no structure, no spirals, no clusters, no cosmic web, only isolated stars floating alone in darkness. Dark matter gave the universe form, the rise of the cosmic web. As the universe grew, the dark matter halos began to link together not by touching, but by gravity. They formed filaments that stretched across hundreds of millions of light years. These filaments connected clusters of galaxies like threads on a grand tapestry. Between the filaments were vast regions of emptiness, cosmic voids. The universe was no longer uniform. It had become a great web, intricate, interconnected, alive with structure. But something else was happening too. The expansion of the universe was slowing. Gravity, especially the gravity of dark matter, was powerful enough to resist expansion. For billions of years, gravity dominated the cosmos. It slowed the stretching of space. It gathered matter into clusters. It allowed galaxies to merge, grow, collide, and evolve. Dark matter ruled, but only for a while, because something else was waiting beneath the surface, something even more powerful. The awakening of dark energy. Dark energy was there from the very beginning, but it hid its presence well. While the universe was small, gravity was strong enough to hold everything together. Dark energy was too weak to matter, but as billions of years passed, space grew larger. Galaxies grew farther apart. Gravity grew weaker on cosmic scales. And when the universe reached a certain size, a certain age, dark energy began to awaken, slowly at first, gently, almost imperceptibly, but as the universe expanded, dark energy became stronger and stronger and stronger, until finally it surpassed gravity. The universe, once held tightly by dark matter, now began to slip away from its grip. Expansion accelerated, galaxies drifted apart faster, the cosmic web stretched, clusters separated, dark energy had taken control, the balance of power shifted. The early universe belonged to dark matter, the present belongs to dark energy, and the future belongs to neither. It belongs to something we do not yet understand. The silence of dark energy. Dark matter works by pulling, dark energy works by pushing, but dark energy does not push in a direction. It pushes everywhere in all directions at all times. It acts like a pressure within space, a pressure caused by space itself. The more space there is, the more dark energy exists. The more dark energy exists, the faster space expands. This feedback loop is slow, gentle, but relentless. And in the far future, dark energy will dominate so completely that the universe will become a place of vast distance, silence, and isolation. A place where galaxies drift beyond visibility. A place where light can no longer travel between island universes. A place where the cosmos becomes empty, not because matter disappears, but because everything is too far apart to ever meet again. Dark matter built the universe. Dark energy will dissolve it. This is the dual nature of the dark universe. One creates, one erases, one holds, one separates, one is gravity, one is anti-gravity. Together, they are the frame and the force that bind the cosmos into the shape we see today. The mystery deepens. We now understand how dark matter shaped the past. We understand how dark energy shapes the future. But the true mystery lies in the present, in the moment we are living right now. Because right now, dark matter and dark energy are in perfect balance. The universe is at a turning point, a cosmic moment between gravity and expansion, between creation and dissolution, between connection and isolation. We exist at the exact age where the influence of dark matter and the rise of dark energy intersect. In all of cosmic history, this moment is unique, and we are living in it. A brief window when the universe is old enough to reveal its structure, but young enough to remain connected. A moment when the dark universe is not just theory, but the true landscape that surrounds us. To understand the future of the universe, we must imagine time on a scale far larger than human history, far larger than the age of Earth, far larger even than the age of the stars. Because the universe does not think in centuries or millennia or even in millions of years, its story unfolds across billions, trillions, and uncountable stretches of time, and as we move forward into its distant future, we enter a world in which the visible universe slowly dissolves under the influence of dark energy. A universe where light grows scarcer, distances grow larger, and the fabric of space stretches itself thin under an invisible pressure. This is the era that awaits us, the slow unfolding silence of everything. The first stage, the separation of galaxies. Today, the universe is filled with countless galaxy spirals, ellipticals, irregular clusters spread across the cosmic web like glowing islands in a vast ocean. But as dark energy grows in influence, space itself begins to expand at an accelerating pace. Galaxies drift away from one another like ships carried by a rising tide. In a few trillion years, every galaxy outside our local group will have moved so far away that their light can no longer reach us. Not because their stars have died, but because the space between us has stretched too quickly for the light to cross. The night sky will grow empty, silent, starless. The universe will feel as though it contains only one cluster of galaxies our own. But this is only the beginning. The second stage, the decline of starlight stars, burn for millions, billions, sometimes trillions of years. But even stars cannot burn forever. The largest stars are the first to vanish. Their lives are brilliant but short. They collapse into black holes or explode into supernovae. Then, slowly, the medium-sized stars fade, stars like our sun. They swell into red giants, shed their outer layers, and collapse into white dwarfs, cold, dense remnants that glow faintly for billions of years before fading into darkness. The smallest stars, the red dwarfs, burn the longest. Some will shine for trillions of years, but eventually all starlight will disappear. The universe will enter the degenerate era, a time of black dwarfs, neutron stars, brown dwarfs, and cold embers of stellar life, a time when the universe no longer shines. The third stage, the era of separation. As dark energy continues to accelerate the expansion, even the largest gravitational structures will begin to drift apart. Clusters that once held thousands of galaxies will slowly lose their distant members. Eventually, only tightly bound groups will remain intact, small islands of matter, drifting separately into the darkness. Even within these clusters, movement slows, collisions become rare, interactions decline. The universe becomes quiet, not because matter has vanished, but because everything is too far apart to influence anything else. Gravity, once the dominant force of the cosmos, surrenders to dark energy is expansion. The fourth stage, the end of star formation. Star formation requires vast clouds of gas, hydrogen, and helium. But over trillions of years, galaxies use up their gas reservoirs. Stars form, shine, and die, and the gas that once fueled new stars is either consumed or expelled into space. Eventually, no new stars can form. The universe becomes a graveyard of failed suns, a place where all that remains are the fading remnants of ancient brilliance. No new light, no new warmth, just the last flickers of what once was. The fifth stage, the black hole era. As stars die and galaxies darken, black holes begin to dominate. They swallow gas, stars, and sometimes even entire systems. Supermassive black holes, once at the centers of bright galaxies, become the last giants in a dimming universe. But even they are not eternal. According to Hawking radiation, black holes slowly lose mass over unimaginable spans of time. A stellar black hole might take 1067 years to evaporate. A supermassive one could take 10 to 100 years or more. But eventually they too will fade. The last giants of the cosmos will evaporate into nothing more than faint whispers of energy. The universe will become nearly empty, a place without structure, without stars, without galaxies, without heat, but dark energy will still remain, expanding, stretching, growing. The final stage, the dark energy horizon. As space expands, regions of the universe drift beyond each other's horizons, not because they move quickly, but because space between them grows too rapidly. Eventually, the expansion becomes so extreme that even atoms find themselves adrift in a sea of expanding emptiness. Protons may decay if proton decay is real, leaving nothing but loose electrons and photons. If proton decay is not real, protons will survive but isolated across unimaginable distances, a universe reduced to individual particles drifting alone in an ocean of infinite silence. This is the Dark Era, the final epoch of existence. But the story may not end there, because the nature of dark energy is still unknown. It might be constant, or it might change, it might strengthen or weaken, it might even reverse someday. Some theories suggest that dark energy could eventually fade, allowing gravity to take control again. Others propose that dark energy will grow so strong it will tear atoms apart the Big Rip. Still others imagine a universe that cycles expanding, collapsing, expanding again like a cosmic heartbeat. And some believe that dark energy is not a force but a hint that our understanding of space is incomplete, that the universe may contain layers we have not yet discovered, dimensions we cannot perceive, fields we cannot measure, realities beyond our observation. The future of the universe depends on answers we do not yet have, but one thing is certain: dark energy is the sculptor of destiny. It is the quiet force shaping the horizon of everything. It is the last chapter of cosmic history and the first page of whatever comes next. If the visible universe is just 5%, if everything we touch, everything we see, everything we are, is only a thin layer floating on top of a vast unseen ocean, then what does that say about reality itself? Because for most of human history, we believed the cosmos was made for us. We thought the night sky was a map, the stars were lamps, and the universe was built from the same matter that makes human bodies, human dreams, human worlds. But today we know the truth is stranger. We're not built from the primary material of the cosmos. We are the exception, the rare, the unlikely. The universe is not made of us. It is made of something else, something invisible, untouchable, unchanged by the passage of light. Dark matter, dark energy, the two forces that control the universe in silence, a universe that hides 95 of itself. Consider this: if the universe were a vast ocean, we've only seen the foam floating on its surface. If the universe were a book, we've read only the last page and assumed we knew the whole story. If the universe were a painting, we've looked only at the highlights and ignored the shadows, even though the shadows hold the shape. Dark matter and dark energy are not minor ingredients. They are the canvas, the frame, the foundation. The visible world is just decoration. Why does the universe hide itself? This question has haunted physicists since the moment dark energy was discovered. Why would the universe choose to hide nearly all of its mass and energy? There are several possibilities. Possibility 1: we evolved too early. Perhaps in the far future, dark energy will become measurable, detectable, touchable. Perhaps we're simply primitive creatures living at the beginning of time, with tools too simple to see the full picture. Possibility 2: the universe protects complexity. Some physicists believe that the balance between dark matter, dark energy, and normal matter is so delicate that changing it even slightly would erase the possibility of life. Maybe the universe keeps the dangerous parts hidden because exposing them would destroy the fragile order that allows planets, chemistry, and life to exist. Possibility 3: reality has layers. A more radical idea: the universe may have layers we cannot perceive. Just as a two-dimensional creature cannot understand height, we may be unable to sense entire dimensions where dark matter and dark energy reside. We see the shadow, not the source. We feel the effect, not the entity. The universe may be larger than we think. When we talk about the universe, we imagine everything that exists. But what if this is not true? What if our universe is just one bubble in a sea of bubbles, a multiverse? What if dark energy is simply the pressure of another universe pushing against our own? Some theories suggest that universes may collide, bounce, or exist like foam on a cosmic ocean. If this is true, then dark energy is not just a force in our universe, but a clue that ours is not alone. The moment we exist in is special. We live at a unique time, a time when galaxies are still visible, starlight still travels, cosmic structures still connect. The universe has not expanded too far, the dark universe is still observable. In the distant future, all galaxies will drift beyond visibility. The universe will become empty, cold, full of silence. No future civilization will be able to detect dark matter or dark energy. They will never see the cosmic web, the expansion of space, the afterglow of the Big Bang. They will believe they are alone in a small static universe. Only we living now in this brief window are able to see the full story. It is as if the universe opened a door for a moment and allowed us to peek into its machinery. What is the final fate of everything? Now we enter philosophy, because the scientific answers are incomplete. There are three ultimate endings. 1. Heat death, the gentle fade. The universe expands forever, stars burn out, matter drifts apart, black holes evaporate, everything cools, everything quiets, time stretches into near infinity until only silence remains. 2. Big rip, the violent end. Dark energy grows, expansion accelerates, galaxies tear apart, solar systems dissolve, atoms split, space-time rips, everything ends in a single, universal tear. 3. Big bounce, the rebirth. The universe expands, then slows, then collapses, then explodes again into a new Big Bang. An eternal cycle of death and rebirth. In this scenario, dark matter and dark energy are simply phases in the heartbeat of the cosmos. Or perhaps the universe never ends. Some believe that consciousness changes the meaning of the universe. That the universe is complete only because we are here to witness it. Perhaps the universe does not end when stars fade or galaxies scatter, but only when the last mind ceases to wonder. In this view, the meaning of the dark universe is not scientific but poetic. The universe is not a machine, it is a story, and we, in this brief moment where dark matter and dark energy meet, are its storytellers. The final mystery. Dark matter holds the universe together. Dark energy pushes it apart. But between them lies a question. Why this balance? Why a universe fine-tuned for complexity, for structure, for life, for thought? Why a universe that hides 95 of itself yet reveals just enough for curious minds to begin asking questions? Perhaps the universe is not silent. Perhaps this hidden world is not an accident. Perhaps the dark universe is the true universe, and we're only beginning to understand the surface. We begin in darkness, not the darkness of night, not the kind created by shadows, or by the turning of a planet, or by the absence of sunlight, but a deeper darkness, a cosmic darkness, a darkness that has existed since the birth of time itself. Because the universe, despite all its galaxies, all its stars, all its glowing clouds of dust, is mostly invisible. In fact, everything we see, every bright point in the night sky, every nebula photographed by powerful telescopes, every planet, every atom, every beam of light makes up only 5% of the universe. 5%. The rest, a staggering 95%, is made of dark matter and dark energy, invisible, untouchable, everywhere but hidden. But to understand why the universe hides most of itself, we must walk through its long, slow evolution, through billions of years of cosmic unfolding, through mysteries that stretch from the beginning of time to the very end. This is the story of the dark universe, the foundation beneath the visible universe, the skeleton beneath the stars, the quiet force that shaped everything long before the first star ever shone. The illusion of light. When we look into the night sky, we see a universe filled with light. But light is deceptive. It draws our attention. It convinces us that what we can see is all that exists. As humans, we evolved to trust our eyes, to believe that the world we see is the real one. But in space, this logic fails, because light is rare, light is fragile, temporary, dependent on a delicate balance of temperature, mass, gravity, and nuclear fusion. Stars, those bright beacons we admire, are the result of billions of years of perfect conditions. They belong to a small window in cosmic history. Long before they existed, the universe was dark, and long after they fade, the universe will return to darkness. The truth is simple. The universe is not a place of stars. It is a place of shadows, briefly interrupted by light. The first whisper of the dark universe. The story of the dark universe begins not with stars but with math. In the early 1900s, astronomers measured how fast galaxies rotate. It was expected that stars on the outer edges would move more slowly than those near the centre, just as distant planets orbit more slowly around the Sun. But that is not what they found. The stars on the edges of galaxies were moving too fast. So fast they should have flown into space. It was impossible unless something was holding them together, something massive, powerful and invisible. This invisible force could not be gas or dust. It was too strong. It was too consistent. It had to be matter we cannot see. Thus began the search for a hidden substance that outweighs normal matter by a factor of 5. A silent scaffold that holds galaxies together. We call it dark matter. The nature of the invisible. What makes dark matter dark is not colour. It isn't black or shadowy. It isn't smoke or fog. It's invisible because it does not interact with light. It doesn't absorb it, doesn't emit it, doesn't reflect it. Light passes through dark matter as if nothing is there. Imagine trying to photograph the wind. You can capture what it moves, but not the wind itself. Dark matter behaves the same way. We see its influence, but not its presence. We see how galaxies spin, how galaxy clusters behave, how light bends around invisible mass, how the universe's structure forms. But we never see the dark matter directly. It is the shadow architect of the cosmos, halos of the invisible. Now imagine a galaxy, the Milky Way, a spiral of glowing stars tens of thousands of light years across. Its bright core shines, its spiral arms curl outward, its stars dance in quiet harmony. But this is only the visible Milky Way. Surrounding it is a halo of dark matter so vast that the visible galaxy floats inside it like a pearl in a shell. This halo is spherical, extends hundreds of thousands of light years, and contains far more mass than all the stars combined. The real Milky Way is not a spiral. It is a giant invisible orb with a small spiral embedded within it. Every galaxy we see is simply the bright outline of an unseen giant, a sculpture of light on a skeleton of darkness. The cosmic web. If we zoomed out to view the entire universe, we would not see a random scattering of galaxies. We would see a structure, a web. Galaxies form along long filaments made entirely of dark matter. These filaments stretch across millions of light years. Where filaments cross, mass accumulates and forms clusters of galaxies. Where filaments thin, vast voids appear. The cosmic web is the true structure of the universe, and it is woven from dark matter. The visible galaxies are simply lanterns hanging on the invisible threads. Dark matter versus normal matter. Normal matter interacts with light forms, Stars and planets collide and heats can be touched and felt. Dark matter passes through walls, passes through planets, passes through your body. Every second does not collide, does not slow, does not glow. In this very moment, trillions of dark matter particles are moving through you without leaving a trace. You don't feel them. You don't hear them. You don't see them. You're surrounded by an ocean of invisible particles every moment of your life. And if dark matter disappeared, the entire Milky Way would fly apart. Stars would scatter, planets would drift, galaxies would lose their shape. Dark matter is not optional, it is essential, yet we still do not know what it is. A greater mystery awaits. As shocking as dark matter is, it is only the first half of the dark universe. Because when scientists measured how fast the universe expands, they discovered something even more unbelievable. The expansion is accelerating, and the only way to explain that is with another invisible force, dark energy. A force that does not pull but pushes. A force that does not gather matter but scatters it. A force that fills the universe with silent pressure. Dark matter builds the universe. Dark energy tears it apart. Dark matter is the architect. Dark energy is the expansion. One creates structure, one dissolves it. Together they form a universe where only 5% is familiar and 95% is waiting in the shadows to be understood. To understand the true nature of the universe, we must travel forward in time. Not into the far future, not into the cold silence that waits the last stars, but into the moment when the universe revealed its greatest secret. It happened quietly, without sound, without colour, without any visible sign. The universe began to accelerate. Galaxies were moving apart faster and faster, as if pushed by an invisible wind. This discovery, made only a few decades ago, changed everything we thought we knew about the cosmos. It forced us to ask, what kind of universe chooses to speed up instead of slowing down? Gravity pulls, that is its nature. Stars attract planets. Galaxies attract clusters. Matter pulls matter. But the universe did not slow. It accelerated. It resisted gravity. It defied logic. It behaved as though something greater was pushing outward an invisible pressure woven into the fabric of space itself. We call this pressure dark energy. The nature of expansion. To understand dark energy, we must first understand what it means for the universe to expand. Most people imagine the universe expanding as though galaxies are moving outward into empty space. But that's not what happens. Galaxies are not flying into emptiness. They're not rockets blasting away from a centre. The truth is stranger. Space itself is stretching. Imagine 2 points drawn on a rubber sheet. If the sheet stretches, the points move apart even though they never move. This is what's happening to galaxies. The space between them expands. Every moment, every second, every breath you take, space grows. And the more space grows, the more dark energy exists. Because dark energy is a property of space. The more space there is, the stronger dark energy becomes. It is a feedback loop woven into reality itself. A silent force with no source. We know what gravity is. We know what electromagnetism is. We know the nuclear forces. But dark energy does not act like any force we know. It does not pull, does not push in any direction, does not weaken over distance, does not collide with matter, does not change with temperature, does not radiate. It is simply there, everywhere, always, constant, unstoppable. It acts like tension in the fabric of the universe, a tension that grows as space stretches. The more universe exists, the more dark energy fills it. This means the universe will never stop expanding, and it will never return to its earlier state. Why the universe accelerates. Imagine balancing on a mountain, suddenly realizing the ground is rising beneath you. That is what scientists felt when they discovered accelerating expansion. Everything pointed to the opposite. Galaxies should slow down. Gravity should win. The universe should cool, relax and settle, but instead it speeds up. The explanation is hidden in the very nature of energy. In physics, energy has mass, and mass curves space. But dark energy has a negative kind of pressure, a property so strange that it causes space to expand faster. If gravity is the universe exhaling, dark energy is the universe inhaling. If gravity builds structure, dark energy dissolves it. This push is not a force acting on matter, it is a property of space itself. Space wants to grow. It wants to stretch, and dark energy is the mechanism through which it does so. The equation of the universe. When Einstein created his equations of general relativity, he added a term called the cosmological constant. He believed the universe should be stable, neither expanding nor contracting, so he added this constant to counteract gravity. Later, when Hubble discovered the universe was expanding, Einstein removed the constant and called it his greatest mistake. But decades later, scientists discovered Einstein was right after all. There is a constant, a pressure, a force hidden in space. That constant is dark energy. Einstein predicted it without realizing what it truly was. He had glimpsed the nature of the universe long before we understood it. Dark energy versus gravity. To understand the future of the cosmos, we must watch the struggle between two forces. Gravity pulls inward, creates structure, forms stars, planets, galaxies. Dark energy pushes outward, destroys structure, separates galaxies forever. For billions of years, gravity dominated. It pulled matter into clusters, shaped the cosmic web and formed galaxies. But as the universe expanded, gravity weakened on large scales. Dark energy, though subtle, remained constant. And now, dark energy has taken control. We live in a dark energy-dominated universe. When the universe changed forever. The transition happened around 5 billion years ago. Before that time, gravity slowed the expansion. After that time, dark energy began to dominate. The era of structure began to end. This shift marks the cosmic turning point. From creation to dissolution. From building to unbuilding. We live in the small window between the rise of galaxies and their eternal separation. A brief moment when the universe is still bright, still full of starlight, still connected. In the far future, this moment will be remembered as the cosmic spring, a short period where the universe allowed complexity to blossom before dissolving into silence. The horizon of forever. Every day, the universe grows larger, galaxies drift farther, clusters thin out, gravity fades. Eventually, distant galaxies will cross the cosmic horizon, a boundary beyond which their light will never reach us again. They will vanish from the observable universe not because they fade, but because the fabric of space separates us faster than light can travel. The night sky will grow emptier, lonelier, quiet. The universe will become a desert of isolated islands of matter. Ours will be one of them. The loneliness of the far future. Imagine a universe where no new galaxies appear, where no stars are born, where gravity no longer forms clusters or structures. Imagine a universe where the cosmic web dissolves thread by thread into a thin mist, a place where all that remains are the remnants of stars, the quiet embers of galaxies, and the silent pressure of dark energy. This is the future that dark energy is building. It is not violent, not explosive, not sudden. It is slow, gentle, inevitable. A faint whisper stretching the universe into a thin, cold silence. Dark energy is not the destroyer of the cosmos. It is the dissolver, the untangler, the increasing distance, the fading of connection. It is the force that will turn a universe of light into a universe of isolation. The secret beneath reality. Dark energy tells us that the universe is not static. It never was. It never will be. Everything we know, stars, galaxies, clusters, is temporary. Not because they die, but because distance will eventually erase them. Light will not reach us. Galaxies will shrink from visibility. The cosmic background radiation will stretch until its wavelength surpasses the size of the observable universe. And then the story of light will end. Dark energy will write the final chapters. The universe will become a place without communication, without interaction, without connection. A kingdom of empty space ruled by silent expansion. Yet even in this fate, one mystery remains. The mystery of why. Why does the universe expand? Why does space grow? Why does dark energy exist? These questions lead us into part 3, where we explore the origins and purpose of the dark universe. To understand the dark universe, we must return to a time so remote that even imagination struggles to follow. A time before stars, before galaxies, before atoms, before the concept of light. A time when the universe was nothing but raw energy, rushing outward in a great expansion that would one day create every element, every planet, every living thing. But in that early chaos, the seeds of the dark universe were already present. Not in light, not in matter, not in anything we can see, but in patterns, in fluctuations, in the invisible architecture that would guide the cosmos for the next 14 billion years. Let us step into that moment. Before darkness, before light. The universe began as a storm of pure energy, temperature unimaginable, density beyond comprehension, motion chaotic in every direction. Particles collided billions of times per second. Antimatter and matter annihilated each other in flashes of power. Fields vibrated with furious intensity. But beneath this chaos, there were tiny imperfections, slight variations in density and temperature so small that if you could see them, they would appear almost perfectly uniform. These imperfections were the seeds of structure. Where there were slightly more particles, gravity became slightly stronger. Where there were fewer particles, gravity became weaker. And these microscopic variations would grow into the large-scale structure of the universe. Dark matter was the first to respond, the first shadow. Dark matter formed within the first fractions of a second, not because it was created first, but because it stopped interacting with the rest of matter before normal particles did. Normal matter protons, electrons, atoms collided, fused, scattered, glowed. But dark matter did none of this. It cooled rapidly, stopped colliding, and floated freely through the storm. While normal matter waited for the universe to calm, dark matter was already moving into position. Like a silent river flowing beneath a storm, it slipped into the crests and valleys of the early cosmos. Dark matter found the tiny regions where gravity was strongest and began to gather. Halos before galaxies. Long before galaxies existed, dark matter formed halos in visible spheres of mass that would eventually trap normal matter inside them. Imagine a black sphere with no light, no reflection, no surface. Yet this sphere exerts gravity strong enough to shape the fate of everything around it. These early halos were enormous, far larger than the galaxies that would form inside them. Normal matter was pulled into these halos like water flowing into a bowl. But normal matter did not fall quietly. It clashed, heated, collided, and eventually cooled enough to form atoms. Only then could the first stars be born. Dark matter did the shaping. Normal matter did the shining. The first light in a dark universe. The first stars were not like modern stars. They were enormous, hundreds of times the mass of the sun. They burned hot, bright, and lived brief lives before exploding as powerful supernovae. These first explosions spread heavy elements throughout the universe: oxygen, carbon, iron, the building blocks of planets, oceans, life. But the distribution of these stars was not random. They formed precisely where dark matter halos were densest. The invisible guided the visible, the shadow sculpted the light. And so began 14 billion years of galaxies forming inside invisible structures. The cosmic web emerges. As time passed, dark matter halos began to merge. Small halos joined larger ones. Clusters collided. Gravity pulled filaments together. On the largest scales, a pattern appeared, a web. A structure more complex than any living organism. Filaments of dark matter stretching across hundreds of millions of light years. Galaxy clusters sitting at intersections like glowing knots. Voids forming in the spaces between. This cosmic web is the true skeleton of the universe. Without dark matter, none of this structure could exist. Dark matter is not a companion to normal matter. It is the foundation. Normal matter learns to follow. When the first galaxies formed, they followed the lines drawn by dark matter. Where dark matter was dense, normal matter cooled and formed stars. Where dark matter was thin, normal matter drifted into the void. Galaxies did not choose their positions. They inherited them from an invisible past. Even today, every galaxy, every cluster, every filament is held together by dark matter gravity. We see the bright threads. But the web beneath remains invisible. The universe enters a new phase. For billions of years, this invisible skeleton held the universe together. Dark matter ruled. Gravity shaped everything. Galaxies merged and collided. Stars formed and died. Black holes grew. Then, around 5 billion years ago, something changed. Something subtle but cosmic in scale. The expansion of the universe began to accelerate. This was not the work of dark matter. This was the beginning of dark energy, the second half of the dark universe. Dark energy had always been there, but gravity was stronger. Only when galaxies drifted apart enough, only when space became vast enough, only when matter spread thin enough did dark energy begin to dominate. This marked a turning point. The universe shifted from creation to expansion, from gravity to anti-gravity, from structure to dissolution. Dark matter shaped the past, dark energy shapes the future, and we live at the exact moment between the two. Why this moment is special? We exist in a narrow cosmic window, a time when galaxies still shine, stars still burn, cosmic structure still exists, light can still travel between clusters, the cosmic web is still visible, dark energy is only beginning its reign. In the far future, dark energy will erase all structure. Galaxies will drift apart beyond visibility. Starlight will fade. Black holes will evaporate. No civilization in the future will know that dark matter or dark energy ever existed. They will live in isolated universes unable to see the cosmic web. Their sky will appear empty. The entire history of structure will be invisible. Only we, in this brief moment, can see the dark universe. Only we can ask the question, and someday perhaps answer it. The final mystery. Why does the universe contain two invisible forces? Why does one shape the past and the other shape the future? Why does 95 of existence hide in the shadows? Perhaps structure and expansion are two sides of the same story. Perhaps the universe needs both creation and dissolution to evolve. Perhaps the dark universe is not the background but the main character, and the visible universe, the stars, the galaxies, the light is just a brief whisper of brilliance in a cosmos made mostly of invisible truths. To understand the destiny of the universe, we must imagine time not as humans experience it in seconds, hours, years, or even lifetimes, but in epochs. A single cosmic epoch can last billions of years. Entire civilizations could rise and fall without noticing even a small change in the stars. But the universe is not static. It evolves with a rhythm so slow that only the cosmos itself can feel its movement. Dark matter built the structure of the universe. Dark energy will dismantle it. To see how this unfolds, we must journey across the vast river of time into eras that no star, no planet, no human mind will ever witness directly. This is the story of the future of everything. The era we live in, the age of light. Today, the universe is still bright. Stars burn in every direction. Galaxies shine like cosmic cities. Nebulae glow in brilliant colours, creating new stars from the ashes of old ones. This is the stelliferous era, the age of stars. It will last for trillions of years, but compared to eternity, this era is only the first page of an unimaginably long book. Even now, the first signs of change are whispering across the night sky. Galaxies are drifting away a little faster each year. The cosmic background radiation is fading. The largest structures are beginning to thin. Dark energy is rising. Gravity is fading. We are living in the final chapters of the bright universe. The first separation galaxies drift apart. As the expansion of space accelerates, galaxies outside our local group move away from us faster than light can bridge the growing distance. Eventually their light will no longer reach Earth, not because they disappear, but because space grows faster than light can travel. Imagine two ships at sea. They do not move, but the water between them stretches infinitely. Their signals cannot cross the horizon. This is the future of the cosmos. One by one, galaxies will vanish from sight. The night sky will dim. The cosmic web will begin to unravel, the island universe. In 100 billion years, only the galaxies of the local group will remain visible. They will merge into a single vast galaxy, a mega-galaxy sometimes called Milkdromeda, the union of the Milky Way and Andromeda. Beyond this island, the rest of the universe will drift beyond our cosmic horizon. No telescope, no matter how powerful, will detect anything outside our cluster. Future astronomers will believe they live in a small, static universe. They will never learn the true structure of the cosmos. The great web of galaxies, once stretching across billions of light years, will become a forgotten memory. The end of star formation. Star formation requires cold clouds of hydrogen gas. But as galaxies age, two things happen. Gas is consumed by new stars forming. Gas is lost through stellar winds and supernova explosions. Eventually, the supply of gas runs out. The universe enters the post-stelliferous era, a time when no new stars are born. The night sky grows, darker as each aging star dies and no young stars replace them. The remaining stars begin to fade. The smallest, longest-lived stars, the red dwarfs, burn quietly for trillions of years. But even they cannot shine forever. The era of red dwarfs. Red dwarfs are small, cool, and incredibly efficient. They burn their hydrogen slowly, quietly, calmly. While massive stars explode after only a few million years, red dwarfs can burn for up to 10 trillion years. This means the final lights of the universe will not be blue giants or yellow suns, but tiny, dim red stars glowing faintly in increasingly empty galaxies. They will be the last candles of the cosmic night. When the final red dwarf dies, the universe enters a new, colder era. The black dwarf era, when stars exhaust their fuel, they collapse into remnants. White dwarfs, neutron stars, black holes. White dwarfs cool slowly over trillions of years. Eventually they become black dwarfs, cold, dark, invisible spheres made of degenerate matter. In this era, the universe will be filled not with shining suns, but with dead, frozen remnants. Galaxies once filled with light will become graveyards of extinguished stars. Darkness will rule. Dark matter holds the last structures together. Even after starlight dies, dark matter halos continue to maintain the structure of galaxies. Though invisible, the halos remain massive. The dead stars, brown dwarfs, and stray planets orbit in the invisible framework long after ordinary light fades. Dark matter keeps the skeleton intact even when the flesh is long gone. But eventually time stretches too far, dark energy becomes too strong, and the cosmic web falls apart. The dissolution of gravity. Gravity, once the architect of structure, begins to lose the cosmic battle. As the universe expands, galaxies drift too far apart for gravity to act effectively. Star remnants drift through increasing emptiness. Even within galaxies, orbits slowly widen as dark energy pushes space between stars. Clusters separate, galaxies thin, gravity weakens, dark energy continues its silent expansion. The black hole era. Black holes dominate the distant future. They are the last giants of the universe, the final structures that remain gravitationally intact. They consume gas, stars, and even other black holes. Galaxies collapse into them. Clusters collapse into them. All matter that can fall will fall. But black holes are not eternal. They slowly evaporate through Hawking radiation. Small black holes vanish first. Medium ones last longer. Supermassive ones persist for up to 1000 years, but eventually they too dissolve. A final whisper of energy fades into space. The dark energy horizon. After the last black hole evaporates, the universe becomes quiet. No galaxies, no stars, no planets, no atoms, if proton decay is real. Just individual particles drifting across unimaginable distances. Dark energy continues its expansion. Everything becomes too far apart to interact, too far apart to collide, too far apart to exchange energy. The universe becomes a sea of isolation, and dark energy is the silent wind that pushes every particle into the vastness forever. The mystery of time. Here we enter the deepest question of all. Does time itself have meaning when nothing changes? In a universe of isolated particles drifting in expanding space, is time still time? Does time require structure, events, motion? Or can time exist even when nothing happens? These questions are no longer scientific, they are philosophical. What is the meaning of future in a universe that has no events left? What is the purpose of time when all change has ceased? Dark energy pushes the cosmos toward this enigma, a time beyond time. Why does the universe choose this fate? Perhaps the universe is not choosing. Perhaps this fate is written into the mathematics of space-time. Or perhaps dark energy is temporary. The universe will slow. Gravity will regain influence, a collapse will occur, and a new Big Bang will rise from the ashes. This is the Big Bounce theory. It suggests that the universe cycles through infinite births and deaths. Each universe expands. Each universe collapses. Each universe is reborn. Dark energy would be the force that prepares the universe for its next creation. A tide that pulls everything apart so it can fall together again. A final thought. The universe is not just expanding, it is changing. It is telling a story with chapters older and longer than anything we can imagine. And the dark universe, the 95 we cannot see, is not the background. It is the story. Dark matter shaped the past. Dark energy shapes the future. And we are living in the exact moment when both forces can be observed at the same time. A moment that will never come again. There's a question that lies beneath all of science. A question older than astronomy, older than physics, older than humanity itself. Why is there something rather than nothing? And if the universe hides 95 of itself in darkness, why are we allowed to witness even the remaining 5? We are now at the end of our journey, the final descent into the meaning of a universe built almost entirely from things we cannot see. To understand this meaning, we must explore 3 layers: the scientific truth, the cosmic truth, the human truth. Each reveals something deeper than the one before. 1. The scientific truth, a universe built from shadows. Modern physics tells us that everything familiar: stars, planets, matter, atoms, light, is only a thin veil over the real structure of the cosmos. The universe is not a place of glowing suns, it is a place of invisible mass and invisible pressure. Dark matter shapes structure, it forms the cosmic web, it holds galaxies together, it sculpts the universe into its shape. Dark energy shapes destiny. It accelerates expansion, it stretches space, it determines the future of everything. Together, they are the framework of the cosmos. We call the glowing stars normal matter, but in truth they are not normal at all. They are the exception. The universe built itself from darkness, from silence, from forces we cannot touch or even comprehend. The visible world is a tiny bloom on a vast invisible root. 2. The cosmic truth. We exist in a unique moment. The most astonishing fact is this: we live during the only cosmic era where dark matter can be seen indirectly, and dark energy can be measured precisely. 1,000 generations before us would never have detected it. 100 trillion years from now, no one will be able to detect it at all. Civilizations in the future will look out into an empty universe and see nothing beyond the borders of their own galaxy. They will believe the universe is small, young, static. The cosmic web will be invisible. The Big Bang will be hidden. The expansion of space will be undetectable. Dark matter and dark energy will leave no trace. Only we now, in this fleeting moment, can witness their effects. We are standing in a window of clarity that the universe will never offer again. We look out at the last moment when the universe is both, full of structure and full of separation, full of light and full of darkness. We live in a cosmic twilight. 3. The human truth. Why we seek the unseen. When humans look into darkness, they ask questions. They imagine worlds that cannot be seen. They search for patterns in emptiness. This is not biology. It is not instinct. This is the nature of consciousness. To seek the unseen is to be alive. And so, we look into the hidden 95 not only with telescopes but with wonder. The universe is not simply expanding, it is unfolding meaning in every direction. And the darkness is not emptiness. It is possibility. It is the unknown from which knowledge emerges. It is the silence from which questions form. It is the background against which existence comes into focus. If everything were visible, we would stop searching. but the universe leaves mysteries so that curiosity can survive. Dark matter holds galaxies together. Dark energy rips them apart. But the meaning of both is found in neither force. It is found in the mind that tries to understand them. A universe that allows itself to be known, consider this. The universe is 13.8 billion years old. Human science is barely 500, yet somehow we arrived at exactly the right moment, with exactly the right tools to uncover its deepest secrets. Why now? Why at the moment when galaxies still shine, and the cosmic background is still visible and the expansion is still measurable? Why at the moment when cosmic history is readable? There are only two possibilities. Possibility 1, it is coincidence, a cosmic accident, an alignment without meaning. Possibility 2, awareness arises only when the universe makes itself knowable. That consciousness appears in the narrow window when the universe can be understood. This would mean that awareness is not accidental, it is timed, that the cosmos has eras for complexity, just as it has eras for stars and galaxies. We exist in a moment designed for observation, a moment when the universe reveals itself to the minds capable of asking. The philosophical reality, are we the universe seeing itself? Some physicists and many philosophers suggest that consciousness is not separate from the universe but a feature of it, a method through which the cosmos understands itself. Think of it this way. Dark matter shapes existence. Dark energy shapes fate. But neither can ask questions. Neither can wonder. Neither can seek understanding. Only consciousness can do that. Perhaps the universe spends billions of years preparing conditions for structures that can think. Perhaps matter reaches a level of complexity and then awakens to awareness. Perhaps the dark universe is not a barrier, but a challenge, a cosmic invitation, a riddle for minds to solve. The final chapter, the universe without us. One day, the universe will be dark. Stars will die. Galaxies will drift apart. Matter will fade. Black holes will evaporate. Time will stretch until events become meaningless. Dark energy will erase structure. Dark matter will become irrelevant. The fabric of the cosmos will grow thin. But meaning will not disappear, because meaning does not depend on the future. Meaning depends on the present. And we exist in the era where meaning is possible. A universe that allowed consciousness to emerge is a universe that allowed itself to be known. We are not permanent, we're not powerful, but we are witnesses. Witnesses to the brief, brilliant moment when the cosmos revealed its deepest truths and told the story of the dark universe. For all our exploration of dark matter and dark energy, one truth remains impossible to ignore. 95% of the universe behaves as if it belongs to a different reality. It is not made of atoms. It does not shine. It does not collide. It does not stop. It does not respond to any force we understand. It is almost as if the dark universe is not just invisible, but foreign, as though these two vast unseen components, dark matter and dark energy, are not part of our universe, but are leaking into it from somewhere else. A deeper place, a hidden dimension, a larger reality that lies just behind the surface of what we can see. This idea has led scientists to a bold possibility. Perhaps the universe we see is not the whole universe. Perhaps we live in a multiverse, a vast cosmic landscape filled with countless realities, each with its own laws, its own forces, its own forms of matter. And the dark universe may be the evidence of these other worlds. Let us explore this deeper possibility. 1. The first clue: gravity is too weak. Gravity is the weakest force known. A small magnet on a fridge can drag an entire metal spoon against the gravity of a whole planet. Why is gravity so weak? Some physicists believe gravity might not be weak at all, but might be spread out across several hidden dimensions. Imagine a flashlight shining into fog. The light disperses, it becomes faint. Gravity may be doing the same thing, leaking into dimensions we cannot see. If this is true, then dark matter may simply be the shadow of matter existing in another dimension. We cannot see the matter, but we can feel its gravity bleeding into our universe. 2. The brain universe. Theory. According to string theory, our entire universe might be a brain, a three-dimensional membrane floating inside a higher dimensional space called the bulk. Imagine a sheet of paper floating in the wind. That sheet is our universe. Other sheets may float beside it, other universes with different rules, different physics, different forms of matter. Dark matter may be the gravitational influence of matter located on a nearby brain. We don't see it because its light is trapped in its own universe, but gravity can travel between universes. We feel its presence from across the dimensional divide. The invisible halos that hold galaxies together may be nothing more than the fingerprints of other universes pressing against our own. 3. Dark energy as interdimensional pressure. Dark energy may also be a clue that our universe is not alone. Some theories propose that the acceleration of expansion is caused by pressure from another universe interaction between brains' tension in higher dimensional space. Imagine two sheets of fabric slowly drifting apart. As they separate, the distance between them increases. Dark energy may be the effect of our universe pulling away from a parallel universe. A slow, steady separation that causes space within our universe to expand faster and faster. If this is true, then dark energy is not a property of space but a relationship between universes. 4. The mirror universe hypothesis. One of the most interesting possibilities is the idea of a mirror universe. Another universe identical to ours but reversed, every particle mirrored, every force inverted. Matter in that universe could appear as dark matter in ours. They cannot interact except through gravity. We see their influence, but never their light. And perhaps they see us the same way as shadows, as invisible mass, as unexplained gravitational halos. Two universes orbiting each other in higher dimensions, each shaping the other without ever touching. 5. The multiverse as an infinite landscape. If the multiverse is real, it may not contain just one or two extra universes, but infinitely many. Some expanding, some contracting, some filled with stars, some empty, some with different physics, some with no atoms, some with no time. Dark matter may be the leftover influence of countless universes existing all around us. Dark energy may be the pressure of their expansion. Our universe may be one bubble in a cosmic ocean of infinite possibilities. And the dark universe may be the faint echo of that infinite ocean. 6. Why we can't see these other universes. If these universes exist, why can't we see them? Because light is confined to our three-dimensional brain. It cannot escape into higher dimensions. It cannot cross the boundary between universes, but gravity can. Gravity may be the only force that interacts across dimensions. This is why dark matter does not shine, does not absorb, does not reflect. It belongs to a place where light cannot reach. We see the gravity. We do not see the source. 7. Could we ever travel between universes? If the multiverse is real, could we ever escape our brain? Probably not. The force keeping us in this universe is enormous, far stronger than gravity. Trying to leave the brain would be like trying to walk off the surface of water. You cannot step into a direction that does not exist for you. We are confined to our universe, but the influence of other universes may still reach us through dark matter and dark energy. They may never touch us, but they shape us. Their gravity writes the structure of our cosmos. Their pressure creates the fate of our expansion. We are alone, yet surrounded. 8. Are we the shadow of another universe? If matter in another universe can appear as dark matter in ours, then it is possible that matter in our universe appears as dark matter in their universe. To them, we are the shadows, the invisible halos, the unexplained mass, the dark matter of a parallel cosmos. In this view, nothing is truly dark. Everything is visible from the correct perspective. We are blind only because our senses were built for one universe, not for all of them. 9. The meaning of the multiverse. If the multiverse exists, then the dark universe is not a mystery to be solved, but a window to a deeper truth. That reality is larger than we can imagine. That existence is not limited to what we can see. That the universe is one chapter in a book with infinite pages. Dark matter may be the ink from another story. Dark energy may be the breath of another universe. We exist in a cosmic neighborhood too vast to comprehend. The dark universe may be the map to everything beyond. 10. The final thought. The universe is not alone. For centuries we believed the universe was all that existed, but the 95 we cannot see suggests a different truth. A truth where our universe is not the center, our physics is not complete, our matter is not dominant, our reality is not singular. The dark universe is not darkness. It is connection. It is the whisper of other worlds touching ours. It is the hidden architecture of a multiverse filled with endless possibilities. And perhaps we're not alone because we were never meant to be. The cosmos is not quiet. It is vast, interconnected, layered with truths we're only beginning to hear. The dark universe is only the first whisper of what lies beyond. Everything we have explored so far, dark matter, dark energy, the cosmic web, the fate of the universe, the multiverse itself, leads us to one final question. A question deeper than physics, deeper than cosmology, deeper than science. What is reality made of? Not matter, not energy, not space, not time. These are pieces, fragments, shadows on the wall. Reality in its deepest form may obey laws that are not written in the language of atoms, but in the language of information, probability and consciousness. Let us walk slowly into that deeper truth. 1. The universe as code. Some physicists believe the universe behaves not like a machine but like a program, not mechanical, computational, not physical, informational. The rules of the cosmos, gravity, quantum mechanics, dark matter, dark energy may be simple instructions executed on a deeper substrate. In this view, matter is information, particles are bits, energy is computation. The universe is the output and the laws of physics are the algorithm. The dark universe may be information encoded in dimensions we cannot access, not matter, not energy, but data. The universe may not be made of stuff, but of rules. 2. The hidden order of chaos. When we observe the cosmos, we see randomness. Stars forming in clouds, galaxies colliding, black holes merging, quantum fluctuations, dark energy stretching space. But beneath this chaos is an order. Patterns emerge in the distribution of galaxies. Symmetry appears in the equations of physics. Balance shows itself in the constants of nature. The laws of the universe are too precise to be accidental. They are tuned for existence. If gravity were slightly stronger, the universe would collapse. If dark energy were slightly stronger, it would tear apart before stars form. If the charge of electrons changed by a fraction, chemistry would fail. Reality balances on a blade of mathematical precision. The hidden universe may be the mechanism through which this balance is maintained. Dark matter governs structure. Dark energy governs expansion. Together they maintain the equilibrium necessary for complexity. They may be the silent regulators of the cosmic code. 3. Are there hidden forces? What if dark matter and dark energy are not separate things but symptoms of a deeper force? A force we have not named, a force we have not detected, a force woven into the geometry of space itself. Some theories propose a fifth fundamental force, modifications to gravity quantum vacuum structure fields that permeate all space-dimensional curvature. In this view, dark matter and dark energy are not objects but effects, like shadows cast by something just out of sight. The true force may lie beneath everything, shaping reality quietly, invisibly, inevitably. We do not see the cause, we only feel the effect. 4. The holographic universe. Here is a strange possibility, one of the most profound in modern physics. The universe may be holographic, not an illusion but a projection, a three-dimensional world encoded on a two-dimensional surface. Just like a hologram contains 3D information on a flat surface, our entire universe might be the 3D projection of information stored on the boundary of space. If this is true, reality is information, consciousness is computation, physics is encoded, space emerges, gravity emerges dark matter, and dark energy are geometric side effects. In a holographic universe, the unseen 95 might be the instructions encoded on the cosmic boundary. We live inside the projection. The dark universe is the source code. 5. Reality as a quantum fabric. At the smallest scale, space is not smooth. It is grainy, shifting, vibrating. Quantum fields flicker with energy even in complete vacuum. Dark energy may be the sum of these fluctuations, the natural restlessness of the quantum fabric. Dark matter may be excitations in fields we haven't detected yet. In this view, the universe is not solid, not stable, not quiet. It is a boiling sea of probabilities. Atoms are patterns, particles are vibrations, space is foam, time is fluid. The dark universe is simply the deeper layer beneath the visible patterns. 6. The universe. Thinking about itself. There is a possibility that crosses from physics into philosophy. If consciousness is an emergent property of complexity, and complexity is only possible in the tiny 5 of matter that we see, then consciousness is the universe's way of observing itself from within the shadows. Think of it. For billions of years, the universe was silent. No minds, no observers, no questions. Just matter, dark energy shaping each other in an eternal dance. Then somewhere, on a small blue planet, a species opened its eyes, and for the first time the universe saw itself. It asked questions about its structure, its origins, its destiny. We are not outside observers. We are part of the system. The universe produced minds, and minds seek to understand the universe. We are how the universe thinks. We are the mechanism through which the cosmos becomes self-aware, and the dark universe is the hidden part that the universe has not yet learned to reveal. 7. Will we ever understand the dark universe? The final question remains, can the 95 ever be revealed? Will we ever detect dark matter particles, understand dark energy, touch the multiverse, decode the fabric of reality? There are 3 possibilities. Possibility 1. Yes, humanity will discover. new detectors, new energies, new dimensions, new particles, new laws, we will uncover the hidden rules beneath existence. Possibility 2, not yet. We're too early, too primitive, using tools that are still toys compared to what future civilizations might build. Perhaps the universe will reveal itself only when minds evolve further. Possibility 3. No, some truths may be forever beyond reach, not because we fail, but because we belong to one layer of reality that cannot access the next. A two-dimensional creature cannot see the third, it can only feel shadows. We may be the same, we may only feel the shadows of realities beyond ours, and that may be enough, because even shadows tell a story. 8. The final reflection, the beauty of the unknown. We often think the purpose of science is to find answers, but the real purpose is to find questions, to uncover mysteries that remind us how vast existence truly is. The dark universe is not a problem to be solved. It is a reminder that the cosmos is bigger than certainty. That wonder is more powerful than knowledge. That mystery is not the enemy of understanding, but the beginning of it. We live in a universe that hides most of itself. But maybe that is the gift, because as long as there is darkness, there will be curiosity. As long as there is silence, there will be discovery. As long as there is mystery, there will be purpose. The dark universe will outlive the stars, outlive galaxies, outlive time itself. But as long as minds exist to wonder about it, the universe will never be truly dark, because we are the light. In every journey through the universe, there comes a moment when the questions we ask are no longer about stars, or galaxies, or dark matter, or dark energy, but about us. About what it means to exist in a universe so large, so ancient, so silent, and so unknowable. This is that moment. The final step in our cosmic journey is not a scientific discovery, but a realization that the universe is not simply out there, it is also within us. We are made of the same elements forged in the hearts of stars: carbon, oxygen, nitrogen, iron. We are built from the dust of supernovas, shaped by gravity, illuminated by the same laws that govern galaxies. We are the universe, made conscious, asking itself the only question that truly matters: why does anything exist at all? 1. The meaning of existence. The universe could have been empty, silent, dark, featureless. It could have been a void with no stars, no matter, no energy, no laws, no time. But it is not. Something exists. Something vast. Something structured. Something beautiful. Something mysterious. The darkest forces of the universe, dark matter and dark energy, did not prevent existence. They made existence possible. Dark matter created structure. Dark energy shaped evolution. Without them, there would be no galaxies, no stars, no planets, no life, no consciousness. The dark universe is not the opposite of creation, it is its foundation. 2. Why the universe allows awareness. We often imagine consciousness as something fragile, rare, accidental. But maybe it is not. Maybe the universe creates consciousness in the same way it creates galaxies. Slowly, inevitably, through the evolution of complexity. Consider this. The universe formed atoms. Atoms formed stars. Stars formed planets. Planets formed chemistry. Chemistry formed life. Life formed minds. Minds formed understanding. Understanding is not an accident. It is the continuation of the universe's complexity. We are not separate from the universe. We are its voice. 3. The universe. Looking back at itself. Every time a mind wonders about existence, the universe is reflecting on itself. Every question is the cosmos becoming self-aware. When we study the cosmos, it studies itself. When we observe starlight, it is starlight observing starlight. When we think about dark matter, we are dark matter thinking about its own role. When we contemplate dark energy, we are part of the expansion trying to understand its own destiny. This is the cosmic mirror. This is the deepest connection between mind and universe. 4. The silence beyond the stars. The universe is overwhelmingly quiet, not because it is empty, but because it is vast. Signals fade, light spreads thin, time stretches, galaxies drift apart until they are no longer visible. Stars die, black holes evaporate. Future worlds will look into the sky and see nothing, a blank canvas, a quiet darkness, and they will never know that the universe was once full of light and structure. We live in the only moment when the universe can be understood, a narrow window between ignorance and isolation. We do not realize how special this moment is simply because we live in it. 5. The beauty of not knowing. The universe hides 95 of itself. At first, this seems unfair, a puzzle with missing pieces, a map with no labels. But perhaps the universe hides not to frustrate us, but to give us purpose. If everything were visible, there would be nothing to discover, nothing to explore, nothing to dream about. The dark universe reminds us that mystery is not an obstacle, it is a gift. Mystery is the force that keeps curiosity alive. Curiosity is the force that keeps progress alive, and progress is the force that keeps consciousness expanding. 6. What lies beyond the universe? When the last star dies, when the last galaxy fades, when the expansion becomes unstoppable, what remains? Some theories say time will lose meaning, space will become empty, particles will drift apart, the universe will turn cold, energy will dilute to near nothing, but others suggest something else. That in the final silence, the conditions for creation reappear. Out of emptiness, a new universe may emerge, a new Big Bang, a new cosmic dawn, a new story. Perhaps existence is a cycle without beginning or end. Perhaps the universe is not a single event but a heartbeat, each heartbeat born from the dark silence of the one before. 7. The final question. Why does the universe exist? We do not know, and perhaps we never will. But there are possibilities. Possibility A, because it had no choice. Existence is the natural state. Nothingness is unstable. Possibility B, because it can. The laws of physics may allow universes to arise spontaneously from quantum fluctuations. Possibility C, because reality seeks complexity. The universe may evolve toward consciousness in the same way that stars evolve from gas. Possibility D, because existence is the universe's way of exploring itself. Perhaps the universe exists for the same reason we ask questions, because wonder is the most natural state of a thinking cosmos. 8. The final reflection, the light we carry. We have travelled through the birth of the universe, the rise of structure, the nature of dark matter, the force of dark energy, the future of galaxies, the end of time, the existence of a multiverse, the hidden laws of reality. And through it all, one truth remains. The universe is mostly darkness, but the darkness is not empty. It is full of meaning, full of structure, full of unseen forces, full of unanswered questions, and we, small, fragile, temporary, carry the one thing that darkness cannot erase: awareness. As long as there is awareness, the universe is not silent. As long as there is curiosity, the universe is not empty. As long as there is understanding, the universe is not cold. We are the spark in a cosmic night that stretches forever. We are the echo of ancient stars. We are the moment the universe pauses and thinks. And perhaps that was the purpose all along.